The moon, our celestial companion, has always captivated humanity. Its familiar face, illuminated by the sun, has inspired countless stories and dreams. Yet the moon's far side, forever hidden from our view, has remained shrouded in mystery. Now, thanks to NASA's Artemis mission, we are finally unlocking its secrets. The Artemis program, with its ambitious goals of returning humans to the moon and establishing a sustainable presence there, is ushering in a new era of lunar exploration. The data sent back from the Artemis missions is revolutionizing our understanding of the moon. We are gaining unprecedented insights into its formation, composition, and the history of our solar system. The far side, in particular, is proving to be a treasure trove of scientific discovery. It's a pristine record of the early solar system, untouched by the geological processes that have shaped the near side. The discoveries being made on the moon's far side are not merely academic. They have profound implications for the future of human exploration. By understanding the resources available to us on the moon, we can pave the way for a permanent human presence beyond Earth. The moon, once a distant object of wonder, is becoming a stepping stone to the cosmos. One of the most surprising findings from the Artemis missions is the stark difference between the near and far sides of the moon. While the near side, with its dark volcanic plains known as Maria, shows evidence of past water activity, the far side is surprisingly dry. This aridity, confirmed by recent rock sample analyses, challenges previous assumptions about the distribution of water on the moon. Scientists believe this dryness is linked to the moon's formation. The leading theory suggests that the moon formed from debris ejected into space after a Mars-sized object collided with Earth billions of years ago. This molten debris eventually coalesced into our lunar companion. However, the distribution of this material was not uniform. The side facing Earth cooled and solidified first, while the far side, exposed to the coldness of space, remained molten for longer. This difference in cooling rates affected the distribution of volatile elements like water, which were more likely to be retained on the cooler, near side. The presence of water on the moon, even in trace amounts, is of paramount importance for future lunar exploration. Water is essential for human survival, and it can also be broken down into its constituent elements, hydrogen and oxygen, to create rocket fuel and breathable air. Understanding the origins and distribution of lunar water is therefore crucial for establishing a sustainable human presence on the moon. There are several theories about how water arrived on the moon. One possibility is that it was delivered by comets and asteroids that bombarded the lunar surface early in its history. Another theory suggests that water molecules could be formed by the interaction of solar wind, a stream of charged particles from the sun, with the lunar regolith. Regardless of its origins, the discovery of water ice trapped in permanently shadowed craters at the lunar poles has opened up exciting possibilities. These icy reservoirs could provide a readily accessible source of water for future lunar inhabitants, reducing our reliance on costly and complex resupply missions from Earth. The term dark side of the moon, often used to describe the hemisphere we never see from Earth, is actually a misnomer. The far side of the moon receives just as much sunlight as the near side. It's only dark in the sense that it was hidden from our view until the advent of space exploration. The moon is tidally locked to Earth, meaning that it always shows us the same face as it orbits our planet. However, this doesn't mean the far side is simply a mirror image of the near side. It has its own unique characteristics. The far side is more heavily cratered, with a thicker crust and a more ancient surface. It lacks the large dark maria that dominate the near side, suggesting a different geological history. The far side's lack of atmosphere and its distance from Earth's radio interference make it an ideal location for sensitive astronomical observations. A radio telescope placed on the far side of the moon would be shielded from the constant barrage of radio waves from Earth, allowing astronomers to peer deeper into the universe than ever before.